Hi, and welcome to the section on math, time, archives, and images. This section is heavily focused on those utility packages that you may find yourself reaching for time and again. You'll be glad to know that the standard library does an excellent job of making these building blocks easy to work with through some straightforward APIs and concepts. We'll learn how to use the math package to handle large numbers as well as rational or fractional numbers and of course complex numbers as well. We'll see how to use the time package to work with time values, perform arithmetic operations between time values, parse time from strings, format time to strings, and work with time zones. We'll also look at using the archive package to tar and zip files together, tweak compression settings, etc. Lastly, we'll have a little fun with the image package while we work through examples that encode, decode, and manipulate image data. Let's do some math. In the first video of the section, we'll see how to work with numbers that would normally overflow our basic integer and float types, as well as experiment with rational and complex numbers. We'll end with a common task that virtually every programmer ends up needing eventually, and that's generating random numbers. Let's get started. The math package is actually one of the most straightforward to navigate in terms of finding what you're looking for. Need the absolute value function? That's abs. Need sine, cosine, and tangent? You guessed it, sin, cos, and tan. There are some packages under the math package that come in handy for things like working with large numbers, complex numbers, and random numbers. Let's start with working with large numbers. In one of our previous videos, recall that we had an integer overflow problem when trying to initialize a variable with a very large number. We can use the int type from the big package to hold this value. One way to do that is by initializing n as a big int and using its setString method to parse that large number as a string. We then output both the value and its type here. In the assignment to M, we're also demonstrating the new int package level function, which takes an int64 as an argument and returns a pointer to an int value. There are several operations we can perform on these values once we have them, including adding, multiplying, and comparing to other int values as we're doing here. The types within the big package open up a world of functionality tailored for computation. Take, for example, the ability to check if an int value is likely to be a prime number in the following example. Here, we're iterating over a slice of pointers to big int values and making use of the probably prime method on each of those values to get back a true or false. There is a long list of such methods that you can experiment with. Working with big floats is not unlike what we do for big ints. For example, given a string representation of pi in this function, we can parse that into a pointer to a big float value. Here, we subsequently print out this large number with 10 digits of precision using the appropriate fumped package verb. The big package also makes it easy to work with fractional or rational numbers using the rat type. In this example, I make use of the new rat package level function to initialize what effectively are the same fractions. We also see how to get the numerator and denominator portions of these fractions. Here too, there is a long list of functionality exposed on this type for you to explore. The standard library gives you the means of working with complex numbers using both the built-in complex function and also the complex package. In this example, I use the built-in complex function to initialize n, passing in my real and imaginary values. M is initialized using a shorthand syntax that also yields a complex value. I then proceed to perform a number of operations with these values, including using the complex package's abs function to obtain the absolute value of the sum of n and m, acos to obtain the inverse cosine of the product of n and m, and so on. The output also includes the type of the resulting values from those operations. Sooner or later, we tend to need a means by which to generate random numbers. The standard library does not let us down here either. The random package comes to the rescue with a few functions that we can use. There are some gotchas, however. Let's use the following example to illustrate. We start out with a list of proverbs that we want to randomly select from. We'd like for every time we run our program for a random proverb to get selected and outputted. We reach for the NN package level function, which sounds like it might work if we give it the upper bound of positive integers to use as we're doing here. As you can see, this is not really working as we'd expect. We seem to always get the same number and therefore the same proverb. This is where you start to appreciate the documentation when it states that the RAND package, and indeed the NN function in that package, provides pseudo-randomness. We can try to solve our problem by changing the deterministic nature of the number generator by giving it a new seed value. Although we see a different proverb than before, here too, unfortunately, we see that the random number is anything but. To really solve our problem, we'll need to seed with a number that changes every time we execute our program. And what is in perpetual state of change? Time, of course. By using the time package and the Unix nano method on a time value to seed our number generator, we're guaranteed to get a random number with each run. We'll see more about the time package in the next video. We then initialize a new RAND type using the new source and make use of that RAND value to obtain our random integer. When we run our program a few times, we see we get the desired randomness we were looking for. That is it for this video, where we covered how to work with numbers that would normally overflow our basic int and float types. We experimented with rational and complex numbers, and we ended with how to properly generate random numbers.